So, what happened at 5:57 a.m. on Wednesday, August 31st, 2011? I'll tell you. NASA's space shuttle program ended. But would it be fully American to give up space exploration? Nah. Frank Transnetti logged a brief history. He said that NASA completed 135 missions in 30 years. And in 1981, it was the first time a space shuttle was reusable. So they were sending something out there that could not come back. It's amazing. It went there and back using the same equipment. Since this scene ended in 2011, how are we supposed to get back to space now? Did Obama think of that? He probably thought, well, Gina, have you ever heard of a space elevator? And I had to look stuff up. So after a month of the space shuttle program shut down, Ruth Netting gave us a stunning peek into the future of space travel. The concept, honestly, is of the space elevator is thrilling. All of the articles I went through to find out about this information, trust me, they were not that thrilling, but I hope to be able to show you how really cool it is and how really viable a space elevator is. So I'm from Miami, Florida. I've been introduced to what is known as Space Coast. They have banks named after space travel. Children play on space shuttles in playgrounds instead of animal figures. Everyone loves space travel here, so I thought I'd submerge myself into this new culture. I wanted to tell you about how space travel used to be, with the space shuttles, and what's in our near future. I'm not talking science fiction here. It's really cool. We'll walk through some of the materials that'll be used, how it'll be produced, and what impacts this could have on communication in our age. Our age, this could happen. Okay, so is the space elevator a new idea? Well, sort of. Let's talk about a shuttle for a second. What is a shuttle? Something that goes from from fixed points back and forth. If you've ever taken the track, it's usually, light rail. It's usually just to two different places or a couple more. An elevator would be a little more stationary than a shuttle, but let's talk about shuttles for a minute. So even though the space shuttle program took place over space the last 30 years, the price of the getting everything going didn't change a whole lot, which is crazy because we've had a ton of new technological advancements, and why has it still costed the same? It should cost less, right? It costed about $10,000 per pound. That's a lot of money. They originally predicted it would be about 50 million a mission, and it ended up coming out to about 500 million a mission. So every trip they spend about $500 million for this shuttle mission. 135 times, that's crazy. Kevin Bosner, a writer for the website howstuffworks.com, he explained it this way. He said, a space elevator is basically a carbon nanotube composite ribbon anchored to a platform offshore way out in the Pacific Ocean, and it has a counterweight way up into space, about 200,000 miles. So basically, an elevator shaft that would send stuff crawling up and down this nanotube ribbon to and from outer space. So I thought, how could I even explain this? Have you ever seen a mover lift a piano from a second-story apartment? It's kind of what it would look like, except, in space. So we're connecting a line between a platform from the ocean and a satellite in space with a huge counterweight, and we're putting something on it that can go up and down. The cool thing about this is every part of this is that it's feasible to do right now, except the one thing they need to do it. They need carbon nanotubes that go 62,000 miles into space. No big deal. Carbon nanotubes are around, but we can't make them that long yet. So let's break this carbon nanotube down. I had to go back to 8th grade math to remember that nano means billion. So this ribbon is composed of carbon that is 1/1000th of a meter thick. Carbon nanotube composite ribbon. It's tiny. So now for the carbon tube. It's graphene. It's the strongest known substance on Earth, according to Bosner, and it is a 1 atom thick layer of carbon. It's about 100 times stronger than steel and about a fifth of the weight. So this graphene is amazing. The carbon nanotube is just a layer of graphene that's rolled into a tube. It looks like soccer ball chicken wire, and it's wrapped around, and that's nanotube. So it's really stiff, but it's flexible. It moves, but it's still super, super strong. And even though it's just a few atoms across, they're like 10 million times as long as they are wide. So once you get these thing going, it's like a guitar string. It's really, really, really strong. But it could be as thin as a piece of saran wrap. So not strong. It'll still be strong, but not enough to snap. Under its own weight and the added weight of a cargo, it's not going to snap. So now, this is how it's produced. You won't make carbon nanotubes. You don't make them, you grow them. So that's really cool. There's a really cool NOVA video on YouTube. It's listed in my references that shows a dude in a lab. He pulls a braided forest of carbon nanotubes, and when he starts pulling it, it gets about 10 feet away, and finally it snaps. It almost floats away because it's like smaller than a human hair. After 4 centimeters, that's about the length it grows. They don't know why it grows, and they don't know why it stops growing. So once we figure that out, we'll get things taken out, taken up into space. Lastly, so the length and the width. Once they get everything, like I said, once they get everything growing to the right length, then we're going to be able to make this space elevator ribbon. So once they bulk up the nanotubes, they would spool it up, and then they would shoot it into space with some kind of spacecraft. And once it's out there, they would start lowering it back into Earth, out toward the middle of the sea while it's still going into space, lowering the ribbon. And then there would be a dude standing on the platform saying, okay, back it down, back it down. They would take it and clip it to the sea platform. I think this could be really incredible. It sounds like it would be really simple to do, yes? And it could create a couple of great impacts. There would be less space junk in space. You'd be able to go up and collect stuff that we had actually shot up into the sky from before. It would also cost a ton less money. It'd be about $200 a pound instead of $2,000 or $10,000 a pound. And then this would be like the new transcontinental railroad. There wouldn't be just one, there would be several. It could connect us to other planets and other galaxies. This could have a huge impact. Well, we're a world of travelers, and we thirst for information. We have a ton of it at our hand at any time, day or night. It's all because of technological advances. In recent history, we wondered about the Pony Express. How is that going to make a difference? Well, that led to advancements in communication and eventually exploration. So all of the communication and travel resources we now enjoy came from somewhere. We learned a little bit about how this new space elevator will work. We learned about the materials to make it and how it grows and what impacts it'll have. CNN International's Dean Irving helped us understand that the carbon nanotube composite ribbon is going to be the next big thing. We just need to figure out the growth, and we're good to go. So hope to see you in space sometime.